This is the old students' lab that is being dismantled and being moved from the Bitan 1 building. This is the Bitan 1 building. We're moving the magnet and the students' lab and everything from here to the new Brandman B building. Here is the new students' laboratory. The NMR spectrometer is also being moved, but to a different floor in the basement to reduce vibrations. Moving an NMR magnet is a very complicated process requiring de-energizing, warming up, breaking the vacuum, re-evacuating, cooling, and re-energizing the magnet. Here we take a deep dive into the process. The work was carried out by the manager of Bruker Israel, who was in the process of training new engineers. This gives us a unique opportunity to obtain detailed explanations of the process. Most of this video is in English, but some of the conversations are in Hebrew. Please activate subtitles if you do not know both languages. It is possible at some risk to move a magnet a few meters across a level floor without de-energizing. Any further is likely to end in disaster. It is also possible to move a cold, evacuated, de-energized magnet with a vacuum across the campus. However, this risks damage to the magnet and is not recommended. We did this once when we lacked the funding to do it safely, and it worked. This time, the move was properly funded, and the complete process was carried out in the recommended manner. This is the new NMR laboratory in the Brandman B building, where we will be bringing the spectrometer. Over here, where I'm standing, should be the magnet, and then on the floor here should be the instrument, and over on this side, on the table, we will have the computer. De-energizing a magnet releases energy and boils off helium, so there must be enough liquid helium in the magnet to allow a good safety margin before de-energizing. Otherwise, the magnet may de-energize spontaneously in a rapid and uncontrolled manner known as a quench that risks damage to the magnet. The minimum recommended is 85% before starting. We topped up the magnet with liquid helium the day before de-energizing. Energizing a magnet is often referred to as charging a magnet. However, this is a bit of a misnomer since there is no electrical charge on the magnet before or after energizing. A magnet is an inductor, not a capacitor. Nonetheless, magnets are often referred to as being charged, discharged, and recharged, rather than energized, de-energized, and re-energized. This work is done by the spectrometer manufacturer's Israeli branch. The manager of Bruker Israel, Itzik Cohen, is assisted by his engineer Amiel Tzror. Today we are taking down the 300 MHz magnet, preparing to send it from here in Bitan 1 to Brandman B. So far we have removed the probe and the bore. The bore is now open because when it is discharged, we need to open the vacuum and then everything will freeze up, so we don't want condensation on all the parts in the bore.
גם את זה לפרק פה?
מה? פה, לא, לא.
ואין מותר בצד השיעור. Good.
Now, I need this one, תוריד את זה, לראות אם זה מתאים או לא. אם זה לא מתאים, לא, נפתח, תוריד את זה. מה?
נפרק לו את הקצה? נפרק לו את הקצה?
לא, זה הרגע פה, לא. תביא את הרגע. ניסה עכשיו...
רגע, יש לנו עוד סט של 400 עכשיו.
אני חושב שהוא יתאים, בוא נלך לראות אותו.
אוקיי, בוא ניסע באוטו לשמה.
כן. כי זה סט ישן שבאותה תקופה כן נתנו עליהם המגנטים סטים.
כן, נכון. אוקיי, בסדר, אז נצא. So what basically happened here is we didn't have the correct charging leads.
To connect back.
Close up the other side, okay?
תביא את השקפה, אני לא כזה תהיה פה.
That one's a shorting rod, right? That's the shorting rod, right?
This one, the shorting, yeah. This is when you take out the fixed shorting plug in the other side, this is for protection. Whenever, ותיקח גם נייר, שים שם ברגע שאתה פותח, יש שם נייר.
אבל זה יוצא החוצה.
מה? אבל נייר חזק. בהתחלה יצא החוצה.
Very tight.
Leave the pressure, when the pressure release. Now, here. No, don't close it.
No, I'm trying to open it.
This is... Do you have another one? This is the biggest one. אוקיי, תביא לי את ה... איפה המותה או עם ההברגה בצד שלו? היה פה שלישי... לא, לא.
You put it on the top. Okay.
מה זה החנקן שם?
לא, בלמה.
So that's helium.
Nitrogen זה פה.
That's it. Now let's remove the shorting plug. Now there's something very charging.
לא אתם עד הסוף, לא יהיה לנו בעיה, אנחנו לא קוראים. Just warm up and take it out. Warm it and take it out. No, not now. It's frozen, it will break. The oven will break.
Warm it up.
I'm just going to lay down in each place. זה לא יושב טוב כאן. מה?
It doesn't sit well
לא,
on the
הנה.
magnet. I had the suspicions.
Yeah. Okay, now we're taking down the cryo shims and we are soon going to do the main coil. So this is the
After
cryo shim.
corrosion will be discharged.
After all, now we are connecting the main coil, right?
It will be starting blowing.
See. We're open now,
Yeah.
so we're beginning to take down the field. So it was actually 0.2 of an amp higher than you thought.
Plus minus, yeah. I'm not sure that I even charged this magnet with this power supply.
איזה... לא האמנתי שזה כזה קל.
So now we are.
אני טוב לי.
לא האמנתי שזה
Now we
כזה
have more magnets and we are.
כל שאתה רוצה לקנות, תגיד לי איציק, אני יותר פה מעילה, אתה יודע. הנה אתה יודע.
הופה.
Now I need you to blow it.
Here, Itzik starts reminiscing about an installation in 1995 from which two excerpts you have seen a few minutes ago. He then talks about our laboratory website. He makes a lot of compliments.
For now you are record.
As long as you don't get enough ice in
You
there
know
to
that
block it.
I have Roy, my installation on the phone, and I think he prepared a movie. I still have it.
In YouTube.
And you know I have to complicate it.
Well, compliment.
Sorry, compliment. There is a group in Brooklyn that people get advice on some application and some things, asking nucleus, how to find, and somebody asked about one of the nucleuses, I don't remember, and asked reference. And one of our application from US recommended your site.
Okay.
Recommended your site, and I was so pleased from that.
Our site, your equipment.
Never mind about the equipment. I mean, this was a pure chemist questions and shift and nucleus and everything. And you have, and I also entered to this, and This is super. A lot of people get now, you know, all application in book and knows about your side.
היי!
אתה רואה? אני מחמם תוך כדי, אני מחמם את זה תוך כדי, זה קפוא. גם זה היה צריך לחמם. תן לי, תן את הדבר. אני מחמם תוך כדי, יהיה לך דקה. נכנסת? אוקיי. אופן? כן. חלש, לא חזק, you can go out because
An attachment to the bottom of the magnet is required to open the vacuum, and they are about to fit it.
עכשיו, לא לדחוף את זה, את הידע, להשאיר בחוץ. אתה רואה את הפקק הזה? עכשיו, אתה צריך להכניס אותו בצורה כזאת. לדחוף אותו הכי חזק שאתה יכול.
אוקיי, שהאורן יעבור אותו.
שזה יהיה פה, כן. ואז... ואז... לא, מה עשית?
ראיתי אותו.
מה החזיק אותו? מה החזיק אותו?
לא, האורן. חשבתי שהאורן יחזיק אותו.
איך האורן יחזיק אותו?
יחזיק, זה נכנס משהו פה בלחץ.
הרגת אותי. בגלל הרגע, כן.
הכל בסדר.
Okay, so now we're going to open the vacuum.
עכשיו אתה צריך את זה, אתה רואה, זה נכנס לפה. ומצד שני, את האורינג הזה תמיד תשאיר ב-90 מעלות איפה שיהיה לנו יותר קל. ואתה רואה את החורים שם? אני ליד החורים?
אני אסתובב לך אותו.
Having de-energized the magnet, the next stage is to warm it up to room temperature. First, the liquid nitrogen is blown out of the magnet. The liquid helium is not designed to be removed mechanically because the emphasis is on insulating it as much as possible. The access to the liquid helium is a 4 mm diameter tube that makes it virtually impossible to siphon out. To boil off the helium, the vacuum jacket is open to dry nitrogen, allowing the helium to warm up by conduction.
I said that I explained the different type of hose or pipes when regarding to liquid nitrogen, because this one is a special one, very expensive one, that when it froze and you touch it, it doesn't break. It doesn't break. The digon and everything, it are very dangerous when it's frozen.
So what we're doing was just blowing out the liquid
currently
nitrogen.
we are putting pressure in one pot and evaporated the nitrogen or evacuate the nitrogen out to the can. And that's it. And you see that the pressure is not big enough because this one is still, because if it will be too enough, it will release. See?
Yeah, if you want, I can...
pressure inside the duo, but now still the pressure is within tolerance.
Okay.
And that's it. So we do simultaneously warm up helium and nitrogen in order to make the vacuum breakage more safe and quicker, without making the complete ball frozen. This is great. According to the plan. We also, I don't know if you took the image, we also connected the vacuum gauge to the magnet. The closer of the magnet is still on the force. When we evacuate everything, we will pour in nitrogen. And how do you know when it breaks? Because we don't hold the nitrogen nipple with nothing. Only the internal vacuum sucking it in. When the vacuum breaks, it will fall down. We don't catch it with O-rings or anything like this. We will show you later.
It's like the screwdriver that fell down.
גם זה, אתה לא... תמשוך את הפלט למטה, תראה מה אתה מצליח.
תמשוך את זה?
כן. תודה.
כן.
שים לב, אין על זה קלם, זה מחזיק אותו.
נכון.
הוואקום, ברגע שהוואקום יישבר, פתאום זה נופל.
כמו מברק.
עכשיו אתה תראה שכל בו מתחיל לעשות בוילוף, מה שאתה תראה פה עכשיו, לצערי הרב, בגלל שיש פה, אתה תראה שגם פה בפנים זה נהיה קר. עכשיו תראה, הכל מתחיל לרתוח כמו בית משוגעים. הורדנו את הרוב. בוא תחמם פה נוציא שגם פה ישחרר לחץ. לא צריך, לא. תייבש אותו אחת, תכניס אותו. רואה? תראה איך ההליום מתחיל לרתוח כמו משוגע?
After the magnet is completely warm, the next stage is to remove the base and the legs and pack the magnet for transport. Great care has to be taken because the tubes in the bore are very sensitive and a distortion or shift of a millimeter during transport can damage it.
אתה זוכר את המספר?
לא, אני פשוט...
6, 7. לא, 6.
אחד יותר למטה.
כן, זה חייב להיות אותו גובה.
אני מסתכל.
אותו דבר שמה. בוא נתחלף, בוא נכניס אותו ולח.
יופי. לפתוח את הרגל למטה עד הסוף?
לא, אתה יכול להוציא את הרגל בכלל. לא, כן. ככה, אתה לא?
צריך את שלושתם ביחד.
אתה צריך את האלה מהתחתון לשחרר, זה לא יעזור לך.
כן, ניסיתי. זה היה?
כן.
איזה גודל זה? 6?
עכשיו, האומנות, אני מוריד, אתה מכוון, תשים לב. המרכז של המגנט צריך לעשות פה. הדפנות שלו, אתה יכול לנתק את זה? זה קרוע כבר, זה לא יעבור לי.
זה קטן, מה נעשה עם ה-1 ג'יגה? אי אפשר לעשות את זה.
1 ג'יגה אני לא נוגע.
בשביל זה יש אותי.
הביאו מנופי אבי בשביל 1 ג'יגה, לא הייתי איציק. אתה כמעט מגיע, שים לב שזה לא יגיע.
הכל פיקס. הכל פיקס. רחוק. לא נוגע בכלום. גם לא תהיה בעיה למטה עם הברים.
אני רואה.
אין שום בעיה.
אני רואה סיגל, אני רואה. כמה המרחק מפה לפה שמה?
איך?
וואלה, בול. זהו. זה מעולה.
To move the spectrometer to the other building, we used Avi Havalot. Avi is the son of Gabi, who appeared in the 1995 clip earlier and has experience in moving NMR spectrometers.
משהו? שמאלה.
תן לו הרמה רגע.
מינוס אחד, נכון? מינוס אחד, כן. תתפוס איתי, שהעגלה לא תברח. לאט לאט. לא, תבוא ברגע. תוריד. עכשיו, תשים את הכיסאות מהחלטות. איפה? Okay, so we have the computer set up. And we wait for the magnet.
Special care is now taken to move the magnet. It is moved slowly on a pneumatic pallet truck to a truck which takes it slowly the 100 meters or so to the new building.
לא עושה יותר מדי גבוה, אתה תסתכל, שים את הרגל ותראה את הגובה של הרגל, תשים את הבסיס ותראה מתי לעצור. אחד עד למעלה. זהו?
רגע, תעצור. עכשיו...
לא, כן. קודם כל פה, כן. קח את כולם.
זה אחד.
תוציא את המברגים בצד השני, אבל לא משנה, אתה יכול לצאת יותר אחר כך. עכשיו, מה שכן, זה, איפה הפתח, זה הולך ככה. אתה רואה? זה ילך ככה. הפתח הזה, אתה רואה?
כן.
בא לפה.
אוקיי.
אוקיי?
אז אנחנו שמים אותו ככה.
בדיוק, ככה.
הנה, אנחנו רואים גם את הרגליים, בוא.
תוריד את הברגים שם למטה, מפריעים לך.
כן.
את הברגים תוריד. עכשיו אנחנו נצטרך קצת להרים את זה כדי שתוכל להכניס את הברגים. או שנוריד את זה קצת. עדיף להוריד.
לא, למה? נרים אותו ונשים את הבורג, כן. לא צריך להוריד את הבורג באולם.
אז תשים אולי איזה משהו אחר כך עם אלה, חשבתי שזה להביא אלה. אני פה אלה, להביא עוד.
יופי. נשים את האחורי קודם כל. האחורי.
זו שנייה, כן. בוא לפה, לשם שאתה עושה.
אם אתה רוצה עכשיו לחזק אותו, זה הזמן.
לא, אבל צריך
זה הזמן.
בואו נוציא את הארגז הזה, בואו נוריד אותו לרצפה, אחר כך נרים אותו עוד קצת, שהוא יחזק.
אז תשאיר אותו כבר, אל תביא את הערך. יאללה, איתי. תשאיר אותו, תשאיר אותו.
שישב על הרצפה. אכפת לי להרים אותו אחר כך.
יופי, אז הארגז הזה.
שנרים אותו.
The magnet insulation has been open to the air for several weeks. The next stage is to pull a vacuum on the insulating jacket. The pressure needs to be around 10 to the minus 6 millibar before cooling. The pump is left attached while cooling to around liquid nitrogen temperature, then closed when cooling to liquid helium.
הוואקום זה משתחרר. בפתח. זה או ייפול או לא נותן כמו שצריך.
No? Which one do you want? This one? Okay.
While cooling with nitrogen, the low oxygen alarm went off. The level still was not dangerous, but the problem is that the alarm automatically alerts the security department. For the re-energizing of the magnet, Itzik brought along his new engineer, Pavel Basmati.
So all set for flushing with helium tomorrow?
Basically, yes. Need the grab. Need the grab. Hold it from the grab. You? But, okay. I need also...
The same movement.
No. Yes, but I need this one to take out, but you have to warm it up. Because I need to close it. You have to warm that the O-ring will not break, so you have to warm
With the
all
heat-
of this.
with the heater?
With the heater, yeah. All of this. Just to make... This is called baffle. This is a pattern. No. These are not suitable to this magnet. Can you bring me the other one? The bigger?
Okay. The magnet has been cooled to around 80 Kelvin, just over the boiling point of nitrogen. It is important to avoid condensing liquid nitrogen because when cooled with liquid helium, it will freeze, insulating the magnet from the surrounding liquid helium and cause a quench on energizing. With the magnet closed, a slight partial vacuum is pulled on and the helium gas added. This is repeated several times, each time lowering the target pressure until refilling helium from a vacuum. Now the non-return valve is fitted. It can be connected to the recycling system.
Don't tight it until I will hold it.
Okay.
Because this is... No. From this angle I don't see it properly. Nice. Right around. Okay. What? Leave it? Forward. Okay? Now it's forward. Okay. Let me get me back. And give me the chair. I'm not tall. down a little bit, more. Slowly. Okay. You don't have to wait for liquid because it's warm. Just bring it slowly. Go down slowly. You don't have any bullshit. This is very bad.
Go.
Yeah. There is no way that just need to see that he is measuring that the gas is flowing. So the pump will take out you will see, this is a black plate that covers it.
Mm-hmm.
So if this is stronger than the vacuum, it will pull out and then we are in the deep shift. So I'm holding it just a few minutes until the two.
Even the counter's getting frosty.
We overloaded the recycling system, so had to release about half of the helium to the air.
Like the food. Less than 100 liters.
Okay.
Probably we did a good job here. Just a moment. Just a moment. Just a moment. So the helium will stay for tomorrow.
Yeah.
So
Well,
we need to receive.
I'm going to get it soon.
And we measure how much we have here. Maybe we can use also here.
We'll see.
So now you can also connect the
I will.
recycle.
As long as it doesn't over pressure again.
Having cooled the magnet and checked that there is no ice forming in the bore and the probe can be inserted ready for energizing.
These two screws. So let's roll it down.
To energize the magnet, a voltage is applied across the coil and the closing wire is heated to make it resistive, non-superconductive. With the voltage applied, the current in the coil and the magnetic field start to rise. After the magnet has reached field, then the closing wire is allowed to cool and become superconductive. Closing the coil and the applied current can be reduced, leaving the magnet on field.
There you will not see it.
Mm-hmm.
Okay? After that, we need to machine.
So we're beginning to charge.
Now, we started at 9:35, charging 0 to 75, 1.8 volts. Helium level was 97%. Okay? We have to write down, monitor, direct, and everything. Something happened, we need it.
Is that the signal? We got it.
Look at it. Yeah, this is the lock. And which field it is? Let's put it here. Basically now, wait 5 minutes, 10 minutes. I mean, the guys say that's how long it takes them to smoke cigarette, but I'm not smoking. So this is between 5 to 10 minutes in this position.
Okay.
And then I will do overshoot.
Mm-hmm.
Overshoot is 0.33%. 0.6. They want 0.6%.
Yes.
So 0.6% of this
From the
0.6
current?
from the last current. This is 84.65
Mm-hmm.
multiplied by 1.6. 85 overshoot to 85.1579. This is 0.6%. Okay? So we open again, we charge it to 85.179.
Mm-hmm.
Wait there, closing. Wait there 5-10 minutes.
Okay.
Open, going back to them. The overshoot just make the magnet more stable.
Okay.
This is the overshoot is doing. Because you are overshoot and come back, so the magnet it will stabilize faster than it was, because every magnet after charging is not stabilized, it's drifting.
Mm-hmm.
So if you do the overshooting, the drift time, I mean the stabilization time is reduced.
Here, Itzik mentions the changes in the energizing procedure of the new EVO model of magnets that we do not have.
The Evo magnet, now you copy with the Evo magnet, you don't need to do it. It's stable after 24 hours, that's it. This will be an excellent magnet. I want to see it, I never installed Evo, but we will install a few of them.
Well, you're going to install a 400 by us for sure.
Yeah. See, drifted already.
Mm-hmm.
See, the same current. I didn't change the current,
Mm-hmm.
and it drifted. See?
Yeah.
Now this is okay. Now 85, 85.
158.
Overshoot is in 50 milli. This is really 50 milli. The main current 85.157.
8.
157.
No. It's almost 8.
7. Now magnet will go away. You will not see it because the field is going up.
Okay, signal's back, right?
We will now close the main. Another coil, which is the lock, that sweep all the time the field, look and stabilize. When you activate it, this is how the FID looks like. If you just want to stop it, you don't go and do stop the sweep,
And it will stay.
and then this will be stable.
Okay.
Okay, so this is not a magnet sweep. This is a sweep that we introduced from the shim coils.
Mm-hmm.
Okay, now it's steady, doesn't move. Now another 5 minutes, and then we will discharge the current from the cable,
Okay.
because now it's looping inside the magnet. Okay. 0.4. Just to have a small test to see that this does
Will
not change.
Okay.
No, did not change. See?
Now we can
Now
go to
it's
0.
80. I like to do it in
Step by step.
Yeah. 0 is basically. And I'm always watching. This should not change, because now we are in persistence mode. It's looping on the magnet. Fix. Okay, now 0. 0, it means that I can take it out. The auto crunching now stay for additional hour.
Mm-hmm.
So we've got to the cryo shimming stage. You're shimming on the lock.
I'm looking on the FID and I'm looking on the lock, of course.
After charging and shimming with room temperature shims, the line shape was still not reaching specifications. So I, with a technician, Orit Cohen from the students' lab, dismantled and cleaned the probe to see if it would help. So this probe, you know how to take it out? You know how to take this one out? Everything's from underneath on this probe. It's unusual. Just a second. This is where everything comes out. And then you've got this strange screwdriver thing to take it out. Okay? Oh, do you have gloves here? Oh, you have gloves, but I think you have to wash them. Oh no, you have to wash them. I've got gloves, I have to wash them because there's traces of soap on the gloves and that will contaminate everything. Now there's 2 screws under here. Now let's see if it works. It doesn't.
לא צריך לשחרר משהו באמצע?
No. Okay. We have a bug. A bug. So we have a little bug here. Let's get rid of it. It was pretty obvious what could be causing the problem with the shimming and homogeneity. We proceeded to dismantle and clean the probe head. Unlike most Brooker probes which have 2 screws holding the cover, this one has 6. While assembling the probe, I mentioned some problems with our DNP NMR, which is managed by Daphne Shimon. Six screws like this. These screws also have to be neutral susceptibility, otherwise you end up with problems like
היה לה ציוד באמת?
The screws in the probe were magnetic.
מה? אבל מי yotzer?
It wasn't made by anyone. Bruker does not do that. Any proper manufacturer of probes won't do that either. I don't know.
ברוקר לא לקחו את כל הציוד שלהם?
No. Take some. Okay, let's go. Let's get in.
The cleaning worked, and we have a line shape for 1% chloroform in acetone D6 that is within specifications. Thank you for joining us on this exciting journey of relocating our NMR spectrometer at the Hebrew University. With our state-of-the-art facility and advanced capabilities, we are proud to offer high-quality NMR services to researchers, industries, and institutions beyond our campus. Whether you're analyzing complex molecules, running sophisticated experiments, or seeking expert insights, we are here to support your work. For more information or to collaborate with us, visit chem.ch.huji.ac.il/NMR. See the description for details. Let's unravel the mysteries of science together.